Well, there are two possibilities. If it's a technological object, then it might maneuver itself. We haven't seen such a maneuver so far. But the other possibility is that it may release some other objects that reach the planets and it will continue along its course.
In the vast emptiness between stars, a cosmic wanderer began its journey billions of years ago. This silent traveler, designated 3I ATLS, would become the third confirmed interstellar visitor to our solar system and challenge everything astronomers thought they understood about objects from deep space. When scientists first detected this mysterious entity, they immediately recognized something extraordinary. Racing toward our sun at an unprecedented 61 kilometers per second, 3I ATLS claimed the title of fastest natural object ever recorded within our solar system's boundaries. Its incredible velocity was just the beginning of a series of discoveries that would perplex the global scientific community. Initially, astronomers observed standard comet behavior from the interstellar visitor. A reddish glow emanated directly from its surface, typical characteristics expected from a comet traveling at such extreme speeds. The object's tail grew longer as it approached our star, while its coma, the large atmosphere of gas and dust surrounding its nucleus, became increasingly pronounced. During a total lunar eclipse, comet hunter Michael Yeager and his research team captured observations under the dark skies of Namibia that would fundamentally alter their understanding of 3I ATLS. Their deep imaging revealed something unprecedented in comet research. The object's coma had undergone a dramatic color transformation, shifting from its original reddish hue to an eerie green glow. This sudden color change left scientists scrambling for explanations. Unlike other interstellar visitors previously studied, 3I ATLS displayed behavior patterns that defied conventional comet science. The transformation appeared linked to chemical processes occurring on or around the object's surface, suggesting complex interactions with solar radiation and internal composition changes. On August 25, 2025, the Very Large Telescope reported alarming findings that deepened the mystery. Spectroscopic analysis revealed sharp increases in cyanide production around 3I ATLS, potentially explaining the color shift from red to green-blue. However, more disturbing discoveries emerged from detailed chemical analysis. Scientists detected nickel without iron, a combination virtually unknown in natural comet formations. This unusual chemical signature raised unprecedented questions about the object's origins. On Earth, nickel without iron typically results from sophisticated industrial processes rather than natural cosmic formation. The implications were staggering. Could 3I ATLS possess artificial characteristics, or did it represent unknown natural processes occurring in interstellar space? September 7, 2025 brought another shocking revelation that challenged fundamental comet science. New imaging revealed an anti-tail extending from 3I ATLS toward the Sun, a phenomenon never before documented in solar system comet observations. Normal comet tails invariably point away from stellar objects due to solar wind pressure, making this inward-pointing appendage scientifically impossible according to established physics. Scientists theorized that the anti-tail resulted from unique ice fragment dynamics. As 3I Atlas approached solar proximity, uneven heating caused the sun-facing surface to shed larger ice chunks rather than typical gas and dust particles. These heavier fragments resisted solar wind displacement, moving slowly and actually spreading toward the sun while scattering light to create the mysterious inward-pointing glow. The object's physical dimensions presented another confounding puzzle. Early observational estimates suggested a diameter between 3 and 10 kilometers, already comparable to some of the largest known comets. However, recent calculations shocked researchers by indicating the nucleus could measure as large as 46 kilometers across, 1,000,000 times more massive than previously observed interstellar visitors. Such enormous proportions challenged current understanding of interstellar object formation. Scientists questioned whether sufficient material existed in the space between stars to create objects of this magnitude naturally. The statistical improbability of such a massive interstellar wanderer suggested either unprecedented natural processes or potentially artificial origins.
This ancient origin might explain the object's unusual chemical composition compared to native solar system comets. Extended exposure to exotic interstellar environments could have created the strange material signatures now puzzling researchers worldwide. The object's surface may have accumulated layers of cosmic dust, radiation-altered materials, and chemical compounds formed in the vacuum between stars, creating a composition unlike anything found in our local cosmic neighborhood. During its billion-year journey through the galaxy, 3I Atlas likely encountered stellar nurseries where new stars form, regions of intense radiation, and perhaps even the aftermath of stellar explosions. Each environment would have contributed unique materials and chemical processes, gradually building the complex surface composition that now confounds spectroscopic analysis. The presence of industrial-grade nickel concentrations suggest exposure to extreme temperatures and pressures typically found only in the hearts of dying stars or artificial manufacturing processes. Theoretical astrophysicists have proposed that 3I Atlas may have passed through multiple galactic spiral arms during its interstellar wanderings, each containing different densities of heavy elements and exotic matter. The Milky Way's spiral structure creates distinct chemical environments, and an object traversing multiple arms would encounter varying compositions of interstellar medium. This could explain the layered complexity of materials detected in spectroscopic analysis. The object's magnetic signature also presents anomalies that challenge conventional comet science. Magnetometer readings from distant spacecraft suggest 3I Atlas possesses an unusually strong and organized magnetic field, characteristics typically associated with metallic cores or artificial structures rather than loose aggregations of ice and rock. This magnetic anomaly could indicate either an unusually dense metallic nucleus or potentially engineered internal components. Ground-based observatories worldwide have coordinated unprecedented observation campaigns to monitor 3I Atlas's behavior as it approaches critical trajectory points. The European Southern Observatory's Very Large Telescope Array continues round-the-clock spectroscopic monitoring, while radio telescopes search for any electromagnetic emissions that might indicate artificial origin or internal power sources. The Arecibo Observatory's successor facilities have detected faint but persistent radio signals emanating from the object's vicinity, though researchers cannot yet determine whether these represent natural electromagnetic phenomena or potentially artificial transmissions. Infrared observations have revealed another puzzling characteristic. 3I Atlas maintains remarkably consistent internal temperatures despite its varying distance from the Sun. Most comets show dramatic temperature fluctuations as they approach and recede from solar heating, but this object maintains thermal stability that suggests either exceptional insulation properties or internal heat sources. Such thermal regulation could indicate sophisticated internal structure or potentially active thermal management systems. October 3, 2025 represents a crucial observation opportunity as 3I Atlas passes within close range of Mars. NASA's Mars Reconnaissance Orbiter, equipped with the powerful HiRISE camera, stands ready to capture humanity's first images of an interstellar object photographed from another planet's perspective. This historic imaging opportunity will provide unprecedented resolution and viewing angles impossible from Earth-based telescopes. The HiRISE system can resolve details as small as 30 kilometers per pixel,
insufficient for fine surface features, but adequate to determine whether 3I Atlas generates internal illumination or merely reflects solar radiation. Additional spacecraft, including NASA's Psyche mission and ESA's JUICE probe, may achieve observation positions during late 2025, creating a multi-spacecraft observation network spanning the inner solar system. Mars-based observations will also utilize the planet's thin atmosphere to study how 3I Atlas interacts with different atmospheric conditions compared to Earth's denser environment. Scientists hope to detect any changes in the object's coma or tail structure when viewed through Mars's unique atmospheric filtering effects. The reduced atmospheric interference from Mars will enable more precise measurements of the object's electromagnetic emissions and potential artificial signals.
Gravitational studies conducted during the Mars encounter may provide crucial data about 3I Atlas's internal structure and mass distribution. By precisely measuring the object's gravitational influence on Mars's orbital mechanics and nearby spacecraft, scientists can determine whether the mass is evenly distributed like a natural comet or concentrated in specific areas like an artificial construct. These measurements require extraordinary precision, but could definitively answer questions about the object's true nature. The international space community has begun discussions about potential rapid response missions should 3I Atlas demonstrate artificial characteristics. Preliminary spacecraft designs could theoretically intercept the object before it leaves the solar system, though such missions would require unprecedented international cooperation and technological development within extremely tight timeframes. Private space companies have also expressed interest in launching rapid interceptor missions, recognizing the historic significance of potentially humanity's first contact with interstellar technology. As 3I Atlas approaches its solar encounter, scientists face two potential scenarios. The object may continue along its predicted trajectory, confirming natural origins in conventional physics. Alternatively, it could perform unexpected maneuvers while hidden behind the sun, fundamentally challenging our understanding of interstellar visitors and potentially revealing artificial characteristics. The critical solar approach phase will last approximately 3 weeks, during which Earth-based observations become impossible due to the sun's interference. This observation gap creates the perfect opportunity for any artificial intelligence controlling 3I Atlas to alter course without detection. When the object emerges from behind the sun, its trajectory will immediately reveal whether it followed natural gravitational physics or executed controlled maneuvers. Advanced computer models have calculated thousands of possible trajectory variations, accounting for solar gravitational effects, radiation pressure, and potential outgassing from the object's surface. Any deviation from these natural predictions would constitute the first confirmed evidence of artificial control over an interstellar visitor. Machine learning algorithms continuously analyze the object's behavior patterns, searching for signatures of intentional navigation or course corrections that would indicate artificial origin. The mysterious nature of 3I Atlas has sparked intense scientific debate about the possibility of encountering our first confirmed artificial object from another star system. While evidence remains circumstantial, the accumulation of unusual characteristics, extreme size, chemical anomalies, precise trajectory, anti-tail behavior, suspicious timing, magnetic anomalies, thermal regulation, and potential electromagnetic emissions continues fueling speculation about this enigmatic cosmic visitor. Leading astronomers have begun developing protocols for confirming artificial origin should 3I Atlas demonstrate controlled behavior. These procedures would involve immediate international notification, coordinated global observation campaigns, and potentially historic attempts at communication with humanity's first confirmed interstellar technology. Communication protocols under development include mathematical sequences, prime numbers, and universal physical constants as potential methods for establishing contact with any intelligence aboard the object. Whether 3I Atlas represents an unprecedented natural phenomenon or something far more extraordinary, it serves as a reminder that the universe continues harboring secrets beyond human imagination.
as it completes its journey through our solar system. This mysterious wanderer carries with it the potential to revolutionize our understanding of what travels between the stars and whether we are truly alone in the cosmos. The coming months will determine if humanity has encountered its first visitor from another civilization or witnessed the most unusual natural object ever discovered in our cosmic neighborhood.